example. My example will be k equals 5, n equals 8, and no packet losses to fading. So that's the most benign possible case in wireless. And in fact, if that were true, we would actually not need indirect TCP. But it helps us to see what's going on. So here's my segments. Here's my time split up into round trip times. So the initial value. So let's remember some TCP terminology. So when a TCP link comes up, and let's assume there's no negotiation of window size. What's the initial congestion window size? 1, right? We start in slow start, which means that we double the size of the congestion window as long as everything's successfully acknowledged until what? One loss or?
See the changes in congestion.
Okay, let's suppose all the packets are acknowledged. There's no congestion, no noise, whatever. We keep doubling the congestion window until what?
Less than k.
So let's assume k is infinity. So there's no congestion. So assuming everything is fine, no congestion, no nothing. I'm thinking of one particular term that we talked about, the threshold. So once we hit the congestion threshold, we keep increasing the size of the window, but just one at a time, 1/3. Okay. So here's my k, which is 5. First round trip time is in 1 packet. We're going to, again, no packet losses to fading, no packet losses to anything other than congestion at the router, this particular router right here. So let's assume that's successful. What's the next, how many segments do I send the next time? 2. Assume that's successful, how many the next time? 4. You'll notice I haven't said anything about the congestion threshold yet. So the initial, does anybody actually know, I don't think I ever said this in class, does anyone know what the initial congestion threshold is, assuming there's no negotiation about that? That's if an error happens. So this is just pure trivia because I've never said this. So it turns out the initial congestion threshold is 64 kilobytes. So I'm just going to assume that's a very large value compared to the size of these segments. I haven't said anything about the size of these segments. So basically I'm going to say the congestion threshold, as far as I'm concerned, is infinite. So I'm just going to keep doubling. Okay, next one.
So the next one, does it jump to 6 or does it know that it's 5?
It doesn't know anything about 5. 8. Okay, so of those 8, 5 get through, and how many go into the buffer? 3. Still, what's the size of the buffer? The buffer is 8. So there's 3 packets, total of 8 spots in the buffer, so that's fine. What's my next? 16. Of which 5 get through, and how many go in the buffer? Well, how many should go in the buffer? How many should, if the buffer was of infinite size, 11. now we got a problem because we tried to get 3 in the buffer. 3 are already in the buffer. We're trying to stuff 11 new ones in the buffer, so we have a total of 14 candidates for the buffer. There's only 8, so these, at least some of these packets get dropped. They don't get acknowledged.
So in this case, does it acknowledge anything? Though?
No, so we're assuming, what did I call it? Cumulative acknowledgement, which means that in this case, the acknowledgement is not sophisticated enough to pick out the ones that got through and the ones that didn't.
But how does the receiver also increments the receiver window size every time it acknowledges? So the first time it's going to acknowledge 1, the next time it's acknowledging 2, and then 4.
Correct.
So they're both that.
So I mean, yeah, they're both agreeing here, but at this point, the acknowledgement does not come back. So what's the new threshold? 8. It's half the current window size. So I go from infinity to 8. And what is my next signal size? 1, because we go back into slow start. My next one, 2. Okay, let's just do this a little faster. 4, 1. Start. Question. Tutor first.
What happens to the packet, to the segments in the buffer?
Okay, so that's why I assumed that during slow start, the size of the buffer is not so large that the size of the buffer is small enough that these packets can get through in slow start. So in other words, these guys would be sent in here. 1, 2, 4, 8, of which 5 are sent and 3 go into the buffer. What's my next? 9. So 8 is the congestion threshold. Because 8 is the congestion threshold, I now increase by 1. So I have 5 get through, and now how many go into the buffer? Or how many should go into the buffer? 4. So how many do I have total in the buffer? 7.
So next week the buffer doesn't drain
No, it can't. It can't because 5 got sent here, so the wireless link is at capacity. These guys go into the buffer. And the next time, since the wireless link is still at capacity, so these guys have to go into the buffer. So there's no room for these guys to get through. The only time these guys can get through is in the slow start, which is why I made that assumption.
So why can't we send 3 and then 2 of these 5 actually go to the?
Oh, I mean, well, it doesn't matter because then you just chop it. So that makes no difference.
So when is the case that the threshold is either they're set to half? It's never set to 1, right? It's always set to half whenever we.
It's always set to half the current window size. The minimum possible value, I never said this, but the minimum possible value is 2. And it can also be affected, and I also never said this, it's not really important for our purposes, but it can also be set to what's called the congestion window advertisement. So if the router suggests a congestion window, then you can set it to that. But otherwise, don't. It's not really important for us. Okay. What's the next? The next
10.
10. Which 5 go here? 5 go here. Any comments on this time instant? Some of these get dropped, so the acknowledgement does not get through, and that gets wiped out. I say these guys get wiped out. They have to be retransmitted. So as far as the network is concerned, it's as though that never happened. Okay. What's my next congestion window?
5.
It's yeah, congestion window. I'm sorry, I misspoke. Congestion window is 1. Congestion threshold